In 2025, scientists monitoring the Horn of Africa watched their instruments light up with anomalies. Deep in the desert, the Earth was doing something it usually takes millions of years to achieve. In real time, the ground beneath the Afar region didn't just shake, it unzipped. Giant fissures, some wide enough to swallow a truck and stretching for miles, tore open the desert floor. This wasn't just an earthquake, it was a separation. We live our lives, thinking the ground beneath us is solid, permanent, and unmoving. But here, in one of the most hostile environments on the planet, that illusion is shattering. A hidden force pulsing deep beneath the crust is actively prying the African continent apart. If you have ever looked at a world map and noticed how the coastline of Africa fits perfectly into South America, you are looking at history. But if you look at East Africa today, you're looking at the future. We are witnessing the birth of a new ocean. I'm the ultimate Trex, and today we are going to the exact spot where the world is breaking to understand the massive geological engine that is rewriting the map of our planet. To understand this story, we have to travel to the Afar region, specifically the Dykes Depression. If you stepped out of a vehicle here, the heat would hit you like a physical blow. Temperatures regularly soar above 115 degrees Fahrenheit or 45 degrees Celsius. It is often called the cruelest place on Earth, a landscape that looks more like an alien moon than a part of our home planet. The ground here is alive. It hisses with escaping steam. It bubbles with neon yellow sulfur springs, and vast salt flats stretch out like frozen white oceans. Dominating the horizon are volcanoes, some long dead, others terrifyingly active. This is the home of Erta Ale, a volcano that holds a rare permanent lake of molten lava. It has been churning and boiling for decades, a window directly into the burning heart of our planet. Yet there is a profound irony here. This harsh volcanic landscape is also the cradle of humanity. It was in these very sediments that the famous fossil Lucy was discovered. In a way, the place where our species began is now the stage for the Earth's next great act. But why here? Why is this specific patch of desert the breaking point for a massive continent? Geologists refer to this area as a triple junction. It is a geological bullseye, a rare point where three massive tectonic plates meet and are pulling away from each other simultaneously. You have the Arabian Plate moving north, peeling away from Africa. Then you have the African continent itself, splitting into two pieces, the massive Nubian Plate to the west and the Somali Plate to the east. Imagine a sheet of thick plywood. If you grab it at three different corners and pull with immense force, the wood will eventually snap in the center, creating a Y-shaped fracture. That is exactly what is happening to the Earth's crust here. Usually, plate tectonics is a game of inches, or rather, millimeters. Plates drift at about the speed your fingernails grow. But in Afar, the crust has been stretched so thin that it acts differently. It has become a fragile skin, scarred by millions of years of tension. And when the pressure builds, that skin doesn't just stretch, it tears open. We tend to think of geological change as slow and invisible, but the Afar region has a habit of reminding us that nature can be sudden and violent. While the 2025 cracks caught the world's attention, a pivotal event occurred in 2005 that changed our understanding of this process forever. In just a matter of days, a series of earthquakes shook the region, and the ground ripped open along a 37-mile stretch. For scientists, this was baffling. A rift of that magnitude should take centuries to form. How did it happen in a week? The answer lies underground. As the plates pull apart, they create a vacuum. Nature abhors a vacuum, so molten rock from the mantle rushes up to fill the void. These are called magma dykes, essentially vertical walls of lava that shoot upward like a liquid crowbar. Imagine driving a wedge into a crack in a log and hitting it with a sledgehammer. That is what the magma does. It forces its way into the crust, pushing the land apart by several meters almost overnight. This confirmed a major theory. The continent isn't just passively drifting apart. It is being actively wedged open by the injection of new crust. But if the plates are the machinery, what is the fuel? What force is strong enough to break a continent? To answer that, we have to look thousands of miles down, deep into the Earth's mantle. Using seismic tomography, which is like a CT scan for the planet, scientists have imaged something colossal beneath East Africa. It's called the African Superplume. Picture a lava lamp. You know how the hot wax rises in a giant slow-motion blob? That is happening inside the Earth. A massive plume of superheated rock is rising from near the Earth's core. When this plume hits the bottom of the African crust, it spreads out. It acts like a blowtorch, heating and softening the rock above it. This heat causes the crust to bulge upward, creating the Ethiopian highlands, and weakens it, making it susceptible to the tearing forces of plate tectonics. This plume is the engine of the split. It pulses like a heartbeat, sending waves of heat and magma upward, driving the rifting process we see on the surface. So, where does this story end? If we fast forward the geological clock, the outcome is dramatic. The Afar Depression is already sinking. In many places, it is below sea level, protected only by low barriers of land that hold back the Red Sea. Eventually, as the stretching continues, those barriers will fail. The waters of the Red Sea and the Gulf of Aden will pour in, not as a tsunami, but as an unstoppable flood. The salt flats will dissolve. The volcanoes will become our islands. The desert will become a new ocean floor. When this happens, the Horn of Africa, including Somalia and parts of Ethiopia, will disconnect entirely. It will drift out into the Indian Ocean, becoming a massive island continent, similar to Madagascar or Australia. Geologists estimate this might take 5 to 10 million years to complete, but the events of 2025 and 2005 show us that the process happens in fits and starts. We are watching the prelude to a global map redesign. While Africa is the most dramatic example, it isn't the only place where the Earth is tearing itself apart. Look at Iceland. The entire island sits directly on top of the mid-Atlantic ridge. You can actually walk, or even swim, in the cracks between the North American and Eurasian plates. Iceland is essentially what the Afar region will look like in the distant future, a volcanic landmass born from a rift. Closer to the United States, we see another glimpse of Africa's future. The Gulf of California is an active rift zone. Millions of years ago, Baja California was part of the Mexican mainland, but rifting tore it away and allowed the ocean to rush in. Some geologists believe this rift is slowly propagating north into the Walker Lane seismic zone. In the distant geological future, parts of California and even Arizona could eventually find themselves on the coast of a new sea, much like the Afar region today. The cracking ground in Ethiopia is frightening to witness, but it is also a reminder of something beautiful. Our planet is alive. Without this tectonic dance, without the recycling of crust and the release of volcanic gases, Earth would be a dead, stagnant rock like Mars. The forces that destroy landscapes are the same ones that build them. They regulate our climate, cycle our nutrients, and create the environments where life evolves. We may not be around to see the first waves crash against the new shores of East Africa, but standing here on the edge of the rift, we are granted a rare privilege. We are witnesses to the Earth in motion, watching the slow, powerful heartbeat of a planet that is constantly reinventing itself. Thanks for watching. If you want to keep exploring the deep mysteries of our world, make sure to hit that subscribe button. Until next time, stay curious